Hello everyone, my name is Saloni Anna Saib Sadi. Currently I am studying MCA first year in Vishwakarma University Pune. I am presenting here data structure project and my topic is queue in data structure. So let's start. First is introduction to queue in data structure. A queue is a linear data structure where elements are stored in the FIFO, first in first out principle, where the first element inserted would be the first element to be accessed. A queue is an abstract data type similar to stack. The thing that makes queue different from stack is that a queue is open at both its ends. The data is inserted into the queue through one end and deleted from it using the other end. Queue is very frequently used in most of the programming languages. What is queue in data structure? A queue is an important data structure in programming language. Queues are often used to manage threads in multi-threading and implement priority queuing systems. Queues are open at both ends with elements inserted at the rear end and deleted from the front end. The front pointer points to the first element in the queue while the rear pointer points to the last element. Queues can be implemented using arrays, linked lists, pointers, or structures. The easiest method is to use one-dimensional arrays. Representation of queue. In data structure, a queue is represented using an array with two pointers, front and rear, that is NQ and DQ, to indicate the queue's two ends. The rear end is used to insert data, which is NQ, while the front end is used to remove data, which is DQ. Now we will see types of queues. Types of queues are simple queue, circular queue, priority queue, double-ended queue, and in simple queue is a linear data structure that follows the first in first out principle where elements are added to the rear and removed from the front. When a new element is added, all elements added before the new element must be deleted to remove the new element. Circular queue. A circular queue is a special case of a simple queue in which the last member is linked to the first, forming a circle-like structure. The last node is connected to the first node, also known as a ring buffer. The nodes are connected end to end. Insertion takes place at the front of the queue and deletion at the end of the queue. Now, priority queue. In a priority queue, the nodes will have some predefined priority in the priority queue. The node with the least priority will be the first to be removed from the queue. Insertion takes place in the order of arrival of the nodes. Double-ended queue, which is DQ. DQ is also known as double-ended queue. As the name suggests, double-ended, it means that an element can be inserted or removed from both the ends of the queue. Now we will see queue operations. Queue operations are NQ, DQ, peek is empty. NQ means insert an element at the rear of the queue. DQ means remove the element from the front. Peek means look at the element at the front without removing it. Is empty, check if the queue is empty. Applications of queues. See, a queue data structure is generally used in scenarios where the FIFO approach, first in first out, has to be implemented. The following are some of the most common queue applications in data structure, that is CPU scheduling, printer queue, breadth first search, handling requests. Advantages of queues. A large amount of data can be managed efficiently with ACE. Operations such as insertion and deletion can be performed with ACE as it follows the first in first out rule. Queues are useful when a particular service is used by multiple consumers. Queues are fast in speed for data interprocess communication. Queues can be used in the implementation of other data structures. Disadvantages of queue. The operations such as insertion and deletion of elements from the middle are time consuming. In a classical queue, a new element can only be inserted when existing elements are deleted from the queue. Searching an element takes O(n) time. Maximum size of a queue must be defined prior in case of error. In case of array implementation. So that's it for today. Thank you so much for watching my presentation.